Hello, boys and girls. Today we will see the next topic or next chapter from the 12th class. And the chapter name is Oscillations. Chapter name is Oscillation. So, before starting the chapter Oscillations, we have seen the last time a motion, that is mean the circular motion. So last time we have seen the circular motion, means a motion which is along the circumference of a circle is called circular motion. So now we will see the another motion called as oscillation. So before considering the meaning of oscillation and its related terms and next topics, first of all see some terms important to understand the topic oscillation. So let us see what is meant by periodic motion. What is meant by periodic motion? Means in world or in nature there are lots of motion which repeats itself after a definite interval of time. Means a motion which repeats itself after a definite interval of time is called as a periodic motion. So last time we have seen circular motion. So let's see. This is a circular motion. The body A is starting its motion from this position and came back to the position A again. Means this is the one circular motion or one set of circular motion, and this motion repeats along the circumference. So this motion, which is called as the circular motion, is repeating along the same path after a definite interval of time. So this is one of the periodic motion. Means example is the uniform circular motion. So uniform circular motion is one of the periodic motion. So in this chapter we will see another type of motion which is also a periodic motion, and that motion is called as the oscillations. Okay, so have you understand what you mean by the periodic motion? Periodic motion means a motion which repeats itself along the same path after a certain definite time or fixed time. It repeats. So next topic is periodic time. So periodic time is, let us consider, this is a circular motion, and this circular motion is suppose uniform circular motion. In this uniform circular motion, particle starts its motion from position A and came back to the position A. Means the body has performed one circular motion, and the time taken by the body to complete its one circular motion or one set of motion. When the body completes its one set of motion and the time taken by the body to complete one set of motion, that definite time is called as the periodic time. So what do you mean by the periodic time? Periodic time means it is the time taken by the body in its motion to complete one set of motion. So such time which is required to complete one set of motion is called as the periodic time, and periodic time is indicated by T. Then next, that is the frequency indicated by N. So what is meant by frequency? So to understand frequency, consider one of the motion just like circular motion. So in this motion, body is performing circular motion, and suppose this is the uniform circular motion, and in this uniform circular motion, body continuously repeating its motion along this circular second or in 1 minute or in 1 hour. Means 1 hour means generally we call as unit time. Generally the time which is we have expressed 1 second, 1 minute, 1 hour, all these times generally we call it as unit time. So suppose the body is performing circular motion and count the number of circular motions performed by the body in unit time. In unit time. So number of motions completed by the body in unit time is called as the frequency. Is called as the frequency. So for an example, suppose this body performing circular motion and completes suppose 2 set of circular motions in unit time. In unit time. So this body is performing or completing 2 set of motions in unit time, means we can say that the frequency is 2. Frequency is 2. Frequency is 2. Suppose the body is performing 5. Body is performing 5 motions or 5 set of motions in unit time, means we can say frequency is 5. Frequency is 5. So what is the general meaning or the definition of the frequency? Frequency means it is the number of motions in periodic motion. It is the number of motions in periodic motions per unit time. Per unit time is called as frequency, and frequency is indicated by n. And we know last time we had considered the relation for frequency, and it is n is equal to 1 upon t. That means the reciprocal of the periodic time is also known as the frequency. That is the mathematical part. From this equation we also can define the frequency, and frequency is reciprocal of the periodic time. So what is basic meaning of the frequency? Frequency means number of motions in periodic time. Number of motions performed by the body in its periodic motion is called as the frequency of the body or frequency of the motion in its periodic motion. So let's see. We know the frequency means number of motions performed in unit time. Number of motions performed in unit time is called as the frequency. So let's see the example of periodic motion. In nature there are lots of motion which repeats itself along the given path. Along the given path after a certain interval of time. Such motions are called as the periodic motion. And periodic motions, one of the example of the periodic motion is the uniform circular motion. So uniform circular motion, it is one of the example of the periodic motion. Now in this chapter, the second motion, that is the oscillation. So oscillation, this is also a certain or one of the example, one of the type of the example or one of the example of the periodic motion. One of the example of the periodic motion. So oscillation is one of the example of the periodic motion. Oscillations is also called as the vibrations. Oscillation has another name called as the vibration. So example of periodic motion. Example of periodic motion. In this chapter we are going to study about the periodic motion, one of the periodic motion, and that periodic motion is called as the oscillation. Because we know oscillation, which is a motion of body, which is to and fro motion of the body, to and fro motion of the body, or up and down motion of the body. Such types of the motion in the body which are to and fro, or up and down motions. Such types of the motions in the nature are known as the vibratory motion or oscillatory motion. So vibratory motion or oscillatory motion or oscillations are periodic because the motion or this motion repeats itself after a fixed interval of time. So such types of the motion are called as the periodic motion. So vibrations or oscillations are one of the examples of the periodic motion. So example of periodic motion. So one of the example of the periodic motion is the vibrational motion or vibration or oscillatory motion or oscillation. So oscillation is one of the periodic motion because it repeats along the same path after a fixed interval of time. So let's see what is meant by the simple harmonic motion. What do you mean by the simple harmonic motion? So let's see the oscillation of vibration. Consider body. When this body moves right, then come back to the original position, and then moves left, and then come back to the original position. Means this body is performing to and fro motion. So this body is moving right and coming back to the original position, and then again continues to the left side and come back to the original position, and this motion or such type of motion is continued. Then we can say that the body is performing oscillatory motion or vibratory motion. Means to and fro motion is nothing but the oscillatory motion. Again, this is the motion which is happening in the horizontal line, along the horizontal line. Let's see the similar example along the vertical line. So this body moves upward direction, then come back to the original position, then moving vertically downward direction, and again come back to the original position. So this is the up and down motion, repeatedly up and down motion. So such types of the repeatedly up and down motion are also known as the oscillatory motion or vibratory motion. Okay. So to and fro motion or up and down motion. So to and fro motion or up and down motions in the nature are nothing but the vibratory or oscillatory motion. So to understand more ideas about the oscillations, so consider one of the best example that we can experience in our daily life, and that is the motion of the body which is attached to the spring, and then when this body is displaced and then release, then the body will perform the to and fro motion along the straight line. Means such a motion is called as the oscillatory motion or vibratory motion or oscillations. Okay, so we will see this is the picture in which the body which is attached to the spring and spring is connected to the fixed support, that means the rigid support. When the body is moved towards right and then release, then the body will perform oscillatory motion. So let's see the figure. Initially, this is the rigid support. This is the spring, and this is the body. And the body is present at this position. Initially, the body is present at this position, its original position, and this original position, which is or where the body is normally present, initially present. So this position is called as the original position or the main position. This body is attached to the spring. Now, this body is displaced. Towards right by the distance x. Means this body is displaced towards right by the distance x, and then release. then release. The body will perform oscillatory motion. Okay, so what happens when the body is displaced towards right? Means this is the displacement of the body towards right through X. At the same time, inside the spring, a force is developed inside the spring, and that force acts on the body. That force acts on the body when the body is at position X. At position X, the force will act on this body, and that force always directed towards the mean position. Directed towards the mean position. When the body is displaced through the distance X, then at that time the force F will act on the body. Force F will act on the body by the spring. So spring will exert force F on the body when the body is displaced by the X, and this force is opposite to that of the displacement. Displacement is along this direction, but at the same time the body will experience a force which is directed towards the mean position. Means displacement and the force in this oscillatory motion is oppositely directed. Let's see the mass of the body. Let M be the mass of the body. This body is displaced by the distance X. Then the body will experience a force F, and this displacement and force are oppositely directed. So when the body is displaced towards right and then release, the body will move towards the mean position. Body will move towards the mean position with increasing speed. Means with acceleration. When the body will reach at the mean position, the body will attain maximum velocity. Where? At the mean position, and continues its motion towards another side. Another side means left side. Body will continue to move along the left side and again displaced through the distance X, will reach to this position. At this position, the body is displaced by again X, and at that position the body will experience the same force F. Let's see the direction of the displacement and the direction of the force. Both directions are oppositely directed. Means in this to and fro motion or oscillatory motion, which is a body which is performing this oscillatory motion, in this oscillatory motion, displacement of the body is always opposite to the force which is acting on the body. Means displacement and the force are oppositely directed in this oscillatory motion. Okay, means if the displacement is more, then corresponding force which is acting on the body will be more. If the displacement is small, the force acting on the body will be small. So what does it mean? Force acting on this body which is performing oscillatory motion, that force is directly proportional to the displacement. But always that force is always directed towards the main position. This is the force directed towards the main position. This is again a force directed towards the main position. Means in oscillatory motion, force acts on the body, and that force is directly directly proportional to the displacement and always directed towards the mean position. Okay, so we can write a relation in this oscillatory motion or oscillation. The force always directed, force always directly proportional to the displacement, but with opposite direction, because the displacement and the force, displacement is right side directed, at the same time the force is left hand side directed, means the directions are opposite. So this negative sign indicates that force is oppositely directed to that of the displacement in this oscillatory motion. So therefore force, now remove this proportionality sign, by the equality sign we can write here negative sign and some constant of proportionality k multiplied by x. So force is equal to minus kx. What is k? K is the constant, that is called as the force constant or force constant or proportionality constant. Okay. Now, when the body is released from this position, it will move towards the main position with increasing velocity. With increasing velocity means the body is accelerating. Means in this motion, body accelerates. Body has acceleration, and acceleration is a vector quantity, and this acceleration, we know acceleration is always directed along the force. Means the direction of the force is nothing but the direction of the acceleration. Means force and acceleration has the same direction. So force and acceleration always directed towards the main position. So we know this is the force, and force means mass multiplied by acceleration. Instead of force, we can write here mass multiplied by acceleration is equal to minus kx. So therefore, acceleration is constant. K is constant. Mass of the body, which is also constant, so ratio will be constant. So therefore, acceleration depends only on the displacement. So acceleration depends on the displacement with the negative sign is opposite direction. So acceleration in this oscillatory motion, acceleration A also directly proportional to the displacement and always directed towards the main position, or always oppositely directed to that of the displacement. Means in oscillatory motion, force and acceleration both. In this oscillatory motion, force or acceleration are directly proportional to the displacement with opposite direction, or directed always towards the mean position. So this is all about the oscillations. But in oscillation, displacement, again velocity and acceleration. In this oscillatory motion, when the body performing oscillatory motion, there are some related physical quantities like displacement, velocity and acceleration. These physical quantity can be expressed in terms of sine or cosine functions. These physical quantities can be expressed in terms of sine or cosine. Sine, cosine are called as the harmonic functions. So sine and cosine are the harmonic functions in terms of which displacement can be expressed, velocity can be expressed and acceleration can be expressed. So these are the harmonic functions to which displacement, velocity and acceleration depends or can be expressed. Therefore, the simple harmonic motion is also called as the harmonic motion. It is also called as the harmonic motion. Oscillatory motion is also called as the harmonic motion because in oscillatory motion displacement, velocity and acceleration depends or can be expressed in terms of the harmonic functions like sine and cosine. Therefore, oscillatory motion is called as the harmonic motion or simple harmonic motion. Harmonic motion or simple harmonic motion. So oscillatory motion is also called as the simple harmonic motion, and there are two types of the simple harmonic motion. First is the linear simple harmonic motion and second is the angular simple harmonic motion. So when the path is straight, when the path of the motion is a straight line and to this line the body is performing oscillatory motion, such types of the oscillatory motions are called as linear simple harmonic motion. Other way, angular simple harmonic motion, when the path is curved and the body is performing oscillatory motion along this curved path, then the simple harmonic motion is called as the angular simple harmonic motion. Okay, already this is all about the oscillatory motion and simple harmonic motion. Now let's see what is meant by simple harmonic motion. This is simple harmonic motion, which is a periodic motion in which force or acceleration is directly proportional to the displacement, and always directed towards the mean position. Means simple harmonic motion means a motion which is periodic in which the force or acceleration is directly proportional to the displacement but always directed towards the mean position. Such types of motions are known as simple harmonic motion. Okay, so this is all about the introduction of the simple harmonic motion.